All right, so once the data becomes useful, how would you go about uncovering the insights from all of it? Can you easily explore the data and then create reports? What about operational dashboards?
Well, here's the thing. While you can use any BI tool for dashboarding, CDB comes with its own built-in tool for data visualization. Aptly named Data Visualization. In the case of this company, data visualization makes it easy for everyone, regardless of skill level, to view and better understand what's going on with their parts. So, in the next demo, our experts will use Cloudera Data Warehouse to run ad hoc exploratory queries, and then they will use data visualization to quickly create, as the name suggests, visualizations that link directly into their data. We'll go through an example of having a manufacturing defect over the course of a week to track down which customers were ultimately affected, and then we'll create a dashboard showing their locations on a real-time map. All right, let's watch the next demo.
Hello, my name is Luis Carrosoni. I'm a Principal Sales Engineer at Cloudera, and now I'll show to you Cloudera Data Warehouse. Cloudera Data Warehouse is a public cloud service that enables self-service data warehousing, data mart, and BI use cases for your business users. It has two main components: database catalogs, where the metadata and secure definitions will be stored. One database catalog can have many virtual warehouses, and virtual warehouse. A virtual warehouse is a set of computer resources that will be used to process and query the data in the object storage of your cloud preferred provider and return results to your business users. To create a virtual warehouse is pretty simple and easy. It eliminates the need and the burden to perform software installation and provision the machine. I just need to click in add the new virtual warehouse. And for example, let's say if I need a new use case to transform the data, perform some massive operations in the data, in the same data that I'm using on the other projects, I need to choose the database catalog, the type of the virtual warehouse that I use, the sizing, if some auto-suspend definitions to keep costs down, the auto-scale, some advanced definitions as well, and I click simply create virtual warehouse. This will create a new set of computer resources based on the configuration that I passed. That after creation, I can use to plug a third-party tool to access this virtual warehouse and query and process the data, or I can pass to another business area to query the data and start using the platform. Here, I have already created a virtual warehouse that I can simply click access to start querying the data directly, and also to explore the tables, all the metadata that we have, the data that we have available for our reports. For example, I have some database here, and I have the factory database that has one table that has some enriched information created by the process earlier, where I can query the data on this table to see the results, explore the results of this table. And for example, let's say if someone asks for a report between a pair that we have made a problem in our engines, I can quickly create this report and export the results for this user. Also here we can see in the results that the address is masked. This is automatically, all because of the integration that we have already with the security policies. And at the end, I can export the results, or I can create a view where this can be a materialized view or not. Materialized view would rewrite the queries on the fly by the optimizer to reduce resource consumption. And also we can integrate with caching techniques where we will reduce even more consumption and of course costs on the infrastructure and also on the Cloudera data platform. Now we can see the view created here, and with this view created, we can use a third-party tool to access the data using JDBC or DBC, or we can use Cloudera data visualization to quickly gain access inside of this data. The first step to start working with Cloudera data visualization is to define a data connection. In order to create a new data connection, we just need to click in here in data, where I have one already created here, but we will create a new one. So I click here in new dataset, the dataset title report engines, beta engines, and from table we can use SQL as well, and the database is reports beta engine 1, the view that we created earlier. Now we can see here ready to use, and after that we can already create a new dashboard directly on the platform, and we can see the results here with the address masked. So all the security policies are also integrated with Cloudera data visualization. And Cloudera data visualization directly, based on the fields that you choose, suggests some visual types for you to start already analyze the data. So I'm selecting here latitude and longitude, which normally is tied to a map. The map is not being shown here, mostly because I need to enter a token access. So let's do that now. Here, I'm clicking here. The server settings is here. In map server, I use Mapbox, so I have the token here. And after I put the token, we can see already the map directly in the platform. Here we have our first dashboard. We can save this dashboard and we can share this dashboard as well with other users. I've created, as I said earlier, data set already. This data set is more advanced, perform joins between other tables. It's not only view. So I have created some other fields also derived on the fields that those tables has. And this is possible also. We have functions in Cloudera data visualization to do this. And I create a dashboard where shows the sales of my entire car factory. Here we can see that the map and also other visualization features. For example, if I choose this model, all the visualization changes between the filter that I choose. Here, for example, the model are the sales is declining. It's a fake data, but this should be concerning for everyone. And at the end, I can create an application, and on this new application, I put the name car sales and the name of the tab car sales. I can create multiple tabs with different dashboards also in one application. For example, I can use the other dashboard that we created first here. Also, I can change some other settings. For example, I can change the logo. Now we are in ClouderaNow. And after it's saved, I can launch this app. And with this, I can share this link and this dashboard to everyone involved that wants to see these results or wants to analyze it. Important to say that under the covers, the tool is sending queries to Cloudera Data Warehouse to process the data, and of course leverage caching and materialized view techniques to be fast. Here, for example, if I don't like this type of dashboard, I can click in Edit, choose a new type of the dashboard here, or use the wizard to identify some viewer options. For me, I will choose this one, the bubble chart, and after I click in Save, all the changes are propagated also to the application, where the users will see the new dashboard and the changes in real time. In the background, I started a process using our new virtual warehouse that we created first, working with the same data, but it is a more heavy process where it does updates, deletes, a normal ELT process. And this process started during our work in Cloudera data visualization, but the performance and also the concurrence didn't affect us because it's a different tenant, it's a different set of computer resource, so we can quick enable and onboard new use case in Cloudera Data Warehouse. Here we can see that the virtual warehouse scaled to the maximum number of nodes. Also, it will auto-suspend based on the time that we choose. And the last thing that I want to show you is Cloudera Workload Manager, where it will enable you to understand the workload that you are running in all of your environment. So here we can see the queries that we sent using Cloudera Virtual Warehouse to the environment. And also we can understand if the best practices are being followed, the resources used by the queries, and this can enable you to understand what's happening to your environment. Going back to Cloudera Virtual Warehouse, just to see if our process are finished, we can see here that the virtual warehouse that we created, it's already stopped and scaled down to 0 nodes, bringing down costs if it's not being used. With that, we saw how easy it is to start query your data, get insights with Cloudera Data Warehouse. Thank you very much.
I'd like to share some additional information on Cloudera Data Warehousing to complement what you just saw in that fantastic demo. At Cloudera, we like to focus more on data warehousing workflows than on features, because it's what you do with the tool that matters more than what the tool does. What you saw was an example of what we like to call the Supercharged line of business analytics workflow. Here, you're really taking advantage of performance features such as caching, materialized views to make sure that your end users' queries run fast and their reports load quickly. And it's also leveraging features like auto scaling and tenant isolation to make sure that SLAs are met even when there's high concurrency and more tenants are being onboarded. But we can be used for many other analytics purposes, all in one platform. So anything from legacy data warehousing offloads, things like Teradata and Oracle and others moving over to the Cloudera data platform, through to operational reporting on live views of data, through to augmentation of your existing reports with text analytics and free text searching. I'll highlight 2 specifically to give you a sense of what we mean by workflows. The first one will be analyze stored data. In this case, we have a line of business user who wants to quickly start running queries or building some dashboards on data that already exists in the cloud, or perhaps it's just on their laptop and they need to upload it. Here, it's all about quickness and agility and self-service. Another good example here is fast analytics on events data. In this case, what we do is we take streaming event data and pre-aggregate it such that subsequent analytics, reporting, monitoring, alerting, slice and dice dashboarding is very, very fast. So a good example here is, suppose you want to have your KPIs and your product quality and performance metrics, but not do it at the macro level, but instead do it for every single customer or every single device that you might be managing. And also make sure that those metrics are updated in real time with live data, and of course scale to however many millions, or in some cases hundreds of millions of customers or devices you might have. That's what we mean by fast analytics on events data. In the next few slides, I'll take you through a few of the key value propositions that we bring to you as you're building out these workflows on the Cloudera data platform. And I'll focus on a couple key numbers that drive the point home. The first one is 5, as in 5 minutes. This is the time it takes to provision for a new tenant up to 3,800 cores of compute capacity and 28 terabytes of total RAM, so they can analyze petabytes of data. This really speaks to the agility we bring to the IT operators who are managing the platform. And what this means is they can use this intelligent containerized compute service, which we call CDW, so that they can get new users on quickly without much fuss. And then once the users are onboarded, they've got a variety of self-service tools that they can use to bring agility to their day-to-day tasks. So whether they're drag and drop visualization dashboard style user, or they want to get in and hack around with a SQL, there's tools for that, both natively in the Cloudera platform as well as third-party tools via integrations with our partners. And of course, let's not forget about security and governance. So we really leverage what's called the SDX, or shared data experience, and that's the central set of all security policies, metadata, schema definitions, lineage, audit trails. And when you bring new tenants onto the platform, they're automatically subscribed, so to speak, to that core set of shared data context. And that way you're not sacrificing your security. You can maintain that impeccable security and governance that you've worked so hard to maintain, and balance that against providing quick capability to the end users for their analytics. So can you do it that fast with your data platform? The next number I'll highlight is 50. This one refers to 50 lines of code. And what this is meant to do is illustrate the ease with which you can build these end-to-end data lifecycle applications within the Cloudera Data Platform. You've probably seen the diagram here on this slide a lot. So the example I'll use for this purpose is an application that's a streaming CDC resolution application. So what that means is we have a source relational database, and all the transactions that happen in that database, it might be your CRM system or ERP system. All those transactions are streamed through to Kafka, picked up in NiFi, stored into the Kudu storage engine for real-time operational reporting. And that entire application that we built was done with less than 50 lines of code in Cloudera Data Platform. And the reason why we're able to build such powerful applications with such little code is we not only have really intelligent engines, but intelligent integrations between the engines. A great example of this is with NiFi and Kudu. These are two Apache projects that we ship within our platform. And what we've done is we've made the integration between those two so tight that you can, just with a couple of nice NiFi processors and less than 10 properties that you configure on those processors, you can have this streaming CDC application built that can handle any number of source database tables and dump the data directly into the Kudu table, corresponding Kudu tables, whether it's an insert, update, or delete, and it's queryable immediately. So just a very few lines of code, in this case, configuration properties even, that need to be set. Another way we can make it so easy to build these applications simply is that we've pre-integrated the most commonly used services that are used in our customers' data warehousing workflows. So a great example here is a very standard thing you might do, which is you get new data in, you need to do some enrichment, cleansing, maybe some feature engineering, and that's usually commonly done in Spark. And you want to update a materialized view within Hive so that your subsequent queries can run really fast. They can hit the materialized view instead of the base tables. And we've got two containerized compute services that do just that. One focuses on Spark for your data engineering purposes, and one focuses on Hive and Impala for your analytics purposes. And we've made it such that you can create Airflow workflows that stitch those two together so that your workflows that need to combine Spark data engineering and then Hive for subsequent data preparation or extract generation, things like that, it's very easy and natural to do. So ask yourself, can you build out such powerful applications with such little effort on your platform? And finally, the last number, this one I cheated, there's actually 5 numbers, but the one you need to really pay attention to is in the bottom left. That's $93.43. So this is the cost it took for Cloudera to compete a TPC-DS benchmark that was run by a third-party firm that was comparing Cloudera data warehousing with a handful of other cloud data warehousing offerings. And so, as you can see here, it was, in terms of price performance, it was cheapest to run the workload on Cloudera compared to all the other offerings. And this is not a surprise to us. Hopefully it's not a surprise to those out there looking at this. We've had these really powerful and fast engines within the open source big data ecosystem for going on a decade now. In this case, Apache Impala was used as the SQL engine. And we're the fastest because we have very efficient execution. It's written in C++. We do a lot of code generation to compile the queries down into a very low level format so they run quickly. A lot of sophisticated multi-threading to drive high CPU utilization. and a lot of caching built in both at the data and metadata layers to make sure that you're not paying any penalty now that all the data lives remotely in object storage. But it's not just SQL engines. We have many other engines that can help with the overall analytics lifecycle, things from OLAP engines, and that's a key one that I mentioned earlier for the aggregated event analytics. That's Apache Druid. And then storage engines. I mentioned Apache Kudu, analytics storage engines, to make it so you can have both updates and fast streaming data, as well as analytics, as well as random access, all in one storage layer. And then, of course, streaming. So it's not just there to get data from point A to point B, but actually doing analytics in the stream with tools like Apache Flink and other tools that we'll be announcing very shortly for doing SQL queries of the data in the stream. So that really complements the end-to-end lifecycle by providing analytics capabilities, again, end-to-end. And it's important to keep in mind that it's not enough just to run fast. We need to make sure we don't overrun our cloud cost budget. It's very easy to do, especially in the public cloud. So we've built in automation to grow and shrink the compute environments so that we can maintain enough capacity to meet your SLAs, but ensure that you're only paying for what you really need, and we turn it off or scale it down when you no longer need it. And so that's how we're able to have great price performance and also not break the budget. So please ask yourself, is your data platform this cost effective? So with that, I'll wrap up. Thank you for the time. If you answered no to any of the questions I asked, please reach out and we'd love to talk to you more. Thanks.